Hello, I love my TDS3012 Tektronix oscilloscope. It's about 26 years old, but the performance is still pretty good even by today's standards. But what really lets it down in this early model is it stores images to floppy disk, which is really impractical. So it makes it hard for me to share with you oscillograms as I'm working on things. I do have an O1 oscilloscope which is connected to the PC, but that has a much lower sample rate and it's not suitable, for example, for some of the material that I need to capture, such as the RF output from video recorders. So it's not really an ideal solution. Oh yeah, hello, Scott.
Where did you get this bag of stuff from?
Oh right. Right. I went and visited an old friend yesterday. His name is Brian. I used to work with him many years ago in a former life, and he gave me some bits and pieces. Shall we investigate what's in this bag? Shall we briefly work through everything that's in this bag, and then we can look in some more detail at some of the items in here. So I'm going to start picking things out at random. Oh, this looks good. DDS function arbitrary waveform generator, 2-channel. I've been using a very basic waveform generator. Let's see if we can find it. So I've been using this from time to time for generating signals. I don't know if you watched my video where I repair the VU meters of a Sony SL-HF100 beta hi-fi video recorder, and I use it for that. So it's okay, but it's only single channel and it's not the easiest thing to use, but you know, it kind of works. This, I think, is going to be quite a lot better. So this can do so much more. It can do modulation and sweep, and I don't know, but it might be able to do a calibrated output, whereas that one, you just turn the gain control. You don't know what your output signal is. So, also this is mains powered rather than using a 5-volt external source. It's got USB, not quite sure why, and TTL outputs and some various inputs as well. So, for modulation, I think. So that is definitely going to be a piece of kit that's going to be set up in my workbench area here. A tiny spectrum analyzer. Okay, I may have shown in the past this TDS3012 has an upgrade option. Well, I bought this, it cost a fortune. It's the FFT upgrade, which allows it to act as a spectrum analyzer, but not a particularly good one. So here we have what's high and low input. It's got USB-C, which presumably is to charge it, a control wheel, and that's, yes, so that's all your control functions there. Some SMA connectors, an antenna. I'm not sure what would have been there. Right, so we're certainly going to enjoy playing with that. But what's this then? Aha, 2. Oh look, okay, we have some adapters there. Right, so another one, so we can play with 2 of these. Okay, they're adapters that allow us to go to BNC. I wonder if this can generate any waveforms high enough that we can view them there. Let's try that later. What else do we have down here? Fluke 52 K-J Thermometer. So I think this is going to be a high precision type K or J thermocouple thermometer. So higher temperature precision than anything I own so far. Not the sort of thing I need every day, but sometimes I do need to measure temperature. I don't know if there's any thermocouples in here, but they're not expensive anyway. What else? Oh, I actually already have one of these. These can come in handy. Just it's great for identifying what component you have in your hand. So it'll give you basic parameters and component types. So where's mine? I've got one here. Exactly the same model. They come in handy when you just don't know what a component is. This might be something else I already have. ESR meter. Do you know this was something, when I first bought my ESR meter, it cost me quite a few bob, and it's like, oh yes, I really need this. So We have an extra one of those. Mine's the ESR60, so it's the same model. I've modified mine. You see how it's already got a hole there? That handily feeds close to the board where you could connect an external switch. So I have a foot pedal connected to mine so that if I press it now, I can operate it without having to press the buttons. So we'll test that later. TV reception systems, antenna and power, and a compass. So you could use this for setting up aerials. I think, could you also use it for satellite? Not sure. It's got F connectors, which is used for satellite. DVB. Okay, so it's specifically for Freeview DVB. Actually, we've just had a new DVB antenna installed. We've got an external company to do it because I'm not going to crawl around on the roof. So we can check we have a good signal with this, and I'm going to hook up an RF amplifier up there, and this will be ideal for testing all that as I go along. Make sure we have a good signal and that the signal goes out to all the sockets in the house. So actually that is going to come in handy. Oh, yes. Oh, you can tell it was raining yesterday. It's got a bit damp. Right, hopefully that'll dry out nicely. So another Atlas product, but this one's the LCR40. Actually says inductors, capacitors and resistors. I've got nothing at the moment to measure inductance with particularly well. I'm wondering also if this could be used for testing video heads. So it says test frequency. How do I change that? No, I don't know what I'm doing. So we'll read the instructions. They'll be available to download. What other goodies do we have? I think we've got two different things here. Let's pull out just one of them. 858D hot air gun. Right, in a somewhat different livery, I have exactly the same thing. Different livery, different make, or apparently different make, but it's the same product, the 858D. But that could be a good thing, because there could be occasions where having two of these could be useful. What do you think? Could you use two hot air guns at once? Maybe. No, I do find these useful, actually. I really like the hot air gun. I mean, there's, it's only a fairly cheap thing, but it really does quite a good job. And I've used this. I was using, well, that one just the other day, working on a professional video recorder where I had to take out a multi-pin chip, and I would have really struggled without a hot air gun. So they're useful. Right. So, oh, this is interesting. This is not a soldering iron as I first thought it might be. So this is, I think, it's a desoldering plunger type thing. Okay. Now I have this, but I do wonder if one of these could actually be handy anyway. And this does have a particularly small nozzle on it, and I was struggling the other day to desolder that same IC actually with very small pins, and the nozzle on this was too big. So even though in theory this should be a better product, I do wonder whether there could be cases where this just gets the job done better. And it's got good blow. I can feel that's a good seal in there. Same make as that. Maybe they came as a pair, those two. Anything else in here? Oh yes. Oh, what's this? It looks like an old oscilloscope probe for something that took 4mm terminals. Some more modern oscilloscope probes. They're only passives, unlike the ones that go on the front of the TDS3012. These are passive. 100 megahertz stroke 6 megahertz. So that'd be 100 megahertz in times 10, 6 megahertz in times 1 mode, I think. And what would you use those with? Maybe something like that. So it's a Hanmatek DOS1102, 110 megahertz, 1 gigasample per second storage scope. So in theory, the performance of this should be quite similar to the TDS3012, but we have the huge advantages here of being a modern device, we can store waveforms out to USB. It has a USB connector at the back, so we could plug that into the PC and capture live as well. Oh, we're going to have some fun playing with this, aren't we? And that and some rainwater is what we have in the bag. Right, we can start playing with this equipment. I'm really excited by this. I'm definitely going to be using this. It's not battery, it's mains only. So we'll see if we can set up some signals on the waveform generator to see if we can compare them on these two oscilloscopes. I don't know what the maximum frequency of this is. It says 14-bit, 250 mega samples per second. So hopefully we can get some good high frequency out of that and compare the operation of the two oscilloscopes. Oh, great stuff. Okay, let's start by switching some of these things on. So we'll switch on the oscilloscope, which is immediately much quieter than the TDS3012 because that has a quite noisy fan in it. And switch on this. Am I doing that right? Oh, what I really need is a BNC to BNC cable, so I'll go and find one of those in a moment. I'll start by just doing the probe calibration on the oscilloscope. Is there an auto set button somewhere? Okay, that's auto set, and it looks like the probes are already calibrated, or that one's calibrated properly. Let's try the other channel. I'm missing the earthing connector for that one, but hopefully we'll get away with just hooking it up. It's looking very good. So we may be missing a few of the accessories here. We need another earthing thing, and I'll need a USB cable for connecting it to the PC. So I'll try and find those. I'll also get a BNC cable to connect it up to the waveform generator. I've just noticed that when I'm moving the position up and down, it's jumping around a lot. I wonder if maybe the rotary encoder is not the best, or is that just an inherent design weakness? You see, it jumps around. It's not at all smooth. You wouldn't have that sort of thing on the TDS3012. The controls are quite intuitive. It's quite easy to work out what you're supposed to do, but wow, that bounces around badly. Let's try channel 2. Oh, that's bouncing around. In fact, if anything, that's even worse. Is that rotary encoder fault, do you think? Or is that just what they do? That's surprisingly bouncy. I mean, when you get it to the position you want, it's fine. It doesn't jump around then. But when you're moving it, it leaps around all over the place. Okay, something to be wary of. Okay, let's see if we can hook these two items up and have a look at some of the signals from the waveform generator. Now, a BNC to BNC connection could result in something of an impedance problem, but let's just see how we get on. I've gone straight into having a signal there. I'm having a bit of trouble connecting my BNC plug though. Let's hit auto set. A nice feature here is cancel auto set. So if you pressed auto set and lost all your settings that you had so carefully configured, you can just go back to where you were, which is a nice idea. Not sure there is a cancel auto set on my TDS3012. Okay, let's have another auto set. Now we have two channels. So function. I don't know what we can do with this. Let's experiment. I'm intrigued by modulation. I love the idea of making a modulated signal. I don't know if you can see the display on this. It's a little bit small, but it appears that we've got a 10 kilohertz frequency output on each channel. So let's increase that somewhat. So on channel 1, I'm increasing it, and we've lost synchronization on the other channel. Okay, we have them both set to 10 megahertz. I'm seeing a little bit of jitter. Can you see that? Which is it? Is it the oscilloscope or the function generator that's giving us the jitter? I dare say one way to find out would be connect it to the Tektronix. Now we'll do that in a minute. But let's wind the frequency up some more. I might go just one channel for a moment. So 60 megahertz is the maximum output frequency, it would appear. and the frequency it's measuring is wandering around a little bit between 59.97 and 60.0 something, 6 or so. I'm going to hook that up to the Tektronix and see if the jitter is still there. I'll do it with just one of the channels, not least because one of the cables is short. Let's have an auto set on this one. A jitter seems to have disappeared, doesn't it? Measure frequency. Well, the frequency itself is still wandering around a little bit, but the display is more stable. But look, you can see the frequency is shifting. Modulation. Let's select some modulation. Okay, so your source can be channel 2 or external, which can be AC or DC coupled. Would that be via one of these inputs? Possibly, but we'll use channel 2, so we'll have a much lower frequency on that. Right, so what I should have, because I've got amplitude modulation on channel 1 from channel 2, I should see an envelope, and I do see it momentarily during the auto set process, but then it disappears, so I'm not terribly clear what I'm seeing. Shall we just compare that to what we get on the Tektronix? On the Tektronix I just hit auto set, and I got something a little bit more obvious, that this is being amplitude modulated. Okay, so I just think the output on the Tektronix is a little bit easier to see, but it may just be a triggering issue. Okay. Right, so we have 100 kilohertz modulation, and if I increase it, we can see on this pink trace the peak widening as we modulate the carrier by more and more of the lower frequency. Now I can switch modulation off and we get a sharper peak. So that's the fast Fourier transform demonstration, and it's at least as good as the one on the Tektronix, if not actually a little bit better. What I'd like to know is how you can detect what frequency that is. How do you measure that frequency? Can I put a cursor on the frequency domain? I know I can do them up here, but can I put a cursor in a frequency domain? Frequency. And it's measuring 5 megahertz, but I thought I was dialing up 55 megahertz. Not quite sure what I've done wrong there. What do you think we will see if we try one of these tiny spectrum analyzers with a similar signal? So we'll need the adapter that allows us to go from BNC. Oh, I think we had that in the other box. Right. Now I don't know if this has been charged up, so that could be an issue. We'll find out in a minute. Okay, well I've centered the tiny spectrum analyzer on 5 megahertz, and with 100 kilohertz modulation I'm seeing peaks either side, and if I increase the modulation I think we see more peaks. So they're a real thing. I'm up to 1 megahertz modulation there. There's a big rise here which I'm not sure what that is. Is that DC? So this is controlled, well, by just this wheel. You press it and step through. It's a little hard to see, to be honest. So if you want to change some parameter, I believe it's also got a touch screen, so you don't have to go through this wheel. Right, I'm really impressed with this, even though I clearly do need to read the instructions. There's clearly a lot to this that I don't yet understand. What I want to do is charge them up as well before I do some more experiments with them. But you can see that that is doing the same function as the spectrum analyzers on the oscilloscopes, only almost certainly to a better degree, but the very small screen, which is kind of lacking in brightness, could make it a bit hard to use in some cases. Okay, let's have a play with some of the other things while I charge these up. Okay, let me show you a few things I've set up here. And I will have to confess, I'm reshooting all this. I did it, I shot this earlier on and got to the end and realised how much I've forgotten since my university days, or Plymouth Polytechnic as it was back then, about modulation and how that looks in FFTs at the frequency domain. So let's just do a few basic things here and look at the FFTs that we can get on this scope and the Tektronix and the tiny spectrum analyzers. Right. So what I have here, channel 1 is my carrier, and I think I've set that to 10 megahertz, and channel 2 is my modulation, and I think I've set that to 1 kilohertz. Let's just have a look at that. So channel 1 1 megahertz, channel 2 1 kilohertz. Right. So here's our channel 2, that's our modulation, and that's our modulated higher frequency, and that's in AM mode. So if now we go to the fast Fourier transform, so we can now see our carrier, and we should see the modulation on there. Let's see if I can make it easier to see. I think there's a button somewhere labelled window that allows me to set, well, I've got cursor, right, and this one, the cursors, I can set into the main window, or the main, the oscillogram, or into the extension, which is the source, which is a math FFT. Right, so we can, where it says line A and B, that allows us to move A or B or both along here. So let's do that. Let's set the cursor. Every time you press it, it tends to slide around. So let's move A, and we should measure the frequency, which is 1 megahertz. How can I open up, expand this area? I don't know, because I presently can't see the sidebands. Maybe I can see them if I make that 10 kilohertz. Maybe you'll see them open up there a little bit. Let's try that. So channel 2, I'm going to set to 10 kilohertz. Oh yes, I think you can see them opening up there. There we go. Just about. I wish I knew how to expand on that. You can just about see those modulation peaks there. Channel 2, I'll increase the frequency a bit more, maybe to 50. There we go, we can see them quite nicely now. So if we look at, we do the cursor and look at B, move B, we should see that well, it's reading 40 kilohertz for whatever reason. Oh, it was 40 kilohertz I dialed in. Haha. There we go. I had dialed in 40, not 50 kilohertz. So good, I actually made a valid measurement there. Okay, now if I move the B cursor, good, we actually get a very valid reading on that. Right, so we'd like to see what that looks like on the Tektronix and also on the Tiny Spectrum Analyzer. But the other thing I'd like to do is FM. Let's do the FM. I think we should see more shoulders, more peaks along the edges. We do, but they're very much in the noise. Perhaps if I have a little bit more modulation. Oh, good. So that's all working as you would expect an FM signal to look. And I could probably detect that on this, especially if I was to use the little antenna that came with the tiny spectrum analyzer. I could probably broadcast that, but that would be highly illegal, wouldn't it? What would happen if I just see if I can pick it up? Oh, I've accidentally switched this to square wave. That would create lots of harmonics all over the place. Let's just fix that. I don't think I can set this to FM mode at this low frequency. Let's try 10 megahertz. Oh yeah, there we go. By setting this down to... I've gotten 10 megahertz FM, 1 kilohertz modulation, and we can pick that up just from the coupling of being near the receiver. And there it is, 2 kilohertz. So there we are. And because it has a modulation input at the back, you could actually just put audio in there and modulate with audio and have yourself an illegal radio transmitter. Right, we're going to go back to something like what we had before so we can look at it on the other scope, but that was just a bit of fun to demonstrate it on a radio. So I've set it back to what it was before, which was a 1 megahertz carrier and 50 kilohertz modulation. Let's feed that now into the Tektronix. Okay, that's what the waveform looks like. So do the fast Fourier transform. Right, so that's it set up on the Tektronix, and it looks very similar, doesn't it? Same sort of waveform. Yeah, that's very good, and we could do, I'm sure, measurements on that as well. So we have the frequency measurement, but what we want is measurements on here. How do we do that? Select measurement for channel 1. How do we select measurement for math? No, the cursor is not in this window, it's in that window. Oh, okay, right, so I have the cursors in the FFT window on here. I'm not quite sure how it was I selected the cursors to be in the FFT window as opposed to the waveform window. I must have pressed a button that did that. It's telling me that the delta between the cursors is 50 kilohertz, so that's absolutely correct. It's doing the same measurement here. Oh, jolly good. I'm glad about that. Right, now let's try the tiny spectrum analyzer. So I've charged these up. Shouldn't matter which one I use. So I have to adapt from BNC to SMA. I might need to take the amplitude down, mightn't I? And I understand that there's a push button, but also touchscreen to set this up. Center frequency, we're at 1 megahertz, aren't we? It's a bit clunky having to step round to find the M. Oh yeah, that's working, I think. Resolution of the display is, well, the resolution display is good, but the text is absolutely tiny. I'm not sure what this noise is up here, whether that's real or not. And why do we go up here? Is that DC component? What are we seeing there? Okay, so you can zoom in quite narrow on this. Can I use this span? How do I do it? No, that was center. How do I get out of that? Span 100 kilohertz. Okay, so when you get the hang of it, it's actually quite good, but you kind of have to put your finger in exactly the right spot on this display. It's quite tricky to get it just the way you want it. But I think you can see it is more capable, actually. It's just I don't know how to use it yet. I haven't read all the instructions. But as a spectrum analyzer, it is actually really impressive. Good, right, we've done all that. Let's see now if we can hook the oscilloscope up to the computer and do real-time measurements. And I wonder if you can do that with this, if that USB allows you to do a similar thing, or if that's charging only. We'll have to experiment with that. Right, so let's switch this one off. I like the fact it's got a physical on-off switch. That's a good idea. Right, I'm going to need a USB
A to B type cable. They're not the most common these days, to go into the USB port at the back of this scope. So I'll come back shortly when I've found such a thing and connected it up. Let's have a look at this software then. So I've installed the software from their website. Presumably I need to start by connecting to the scope. I don't quite know what to do there. Port settings maybe. Connect refresh. What does that do? Oh, unknown error. The program will be shut down. Null. Brilliant. That's not a great start, is it? I'll try again. That was disappointing. How do I connect? Because I have the USB cable connected. I'll unplug it and plug it in again. So that's definitely connected. So how do we connect to the scope? LAN or USB? There's no LAN port on this scope. Maybe there's versions that there are. Available ports, and it's completely blank. There's a sentence down here that doesn't actually make any sense. For there is a limit number of... That's not English. So we're struggling because we can't seem to connect. It seemed to think it was there, but it's not. Let's have a look at the device manager. A live USB Win32 device. So it's that. Do we have to install some other driver first? I may have to do some reading. I do have the Zadig USB driver. Is that relevant to this problem? No, I don't think it is. Okay, so actually it says I've done that wrong. I have to go utility function configure device switch to PC. Ah, right, of course. You have to configure this to work with the rear USB port. Okay. Utility configure device PC. Oh, it was set already. No, that was correctly set already. So if that's already correctly set to PC, and we did the right thing in the software, we went to connection USB device port, then I don't know why it doesn't work. Run the software, click communications, port settings, and choose connect using USB, which it already is. After connecting successfully, well, it doesn't actually say that, but it's what it means. The connection information in the bottom right corner of the software will turn green. Well, it's not. Reinstall USB driver. Oh, okay. Not sure what that's about. Cannot find reinstall.bat. This is terrible software. Really terrible. This is just awful. Oh dear. I'm beginning to think there's no more I can do. This is just not going to work, is it? Oh look! It's suddenly come on. Okay. 1, device 0, refresh. Do I hit refresh or is it going to crash like it did last time? Right, okay. Waveform, image, or high memory depth? Get data now. Aha! Right. Now we're getting somewhere. Okay, I don't have the whole waveform. I only have the waveform. I don't have the math. So really what is the screen? 2 FFT. Okay, right, I've got that too now. It was a different colour though. I was kind of hoping for a live kind of waveform that I can continuously monitor, so I could capture it with OBS. And when I'm working on something, I can show you the oscillograms as I go along. For example, the FM envelope of a video recorder. That's not something I'm finding just yet. It's better than mucking about with floppy disks, because I'd have to do with the Tektronix. But can I do live video? Right, I'm going to have to go off and do some research. The 01 oscilloscope, is PC only, so it doesn't have its own screen. But it can do, it has to do, of course, live video. So it's not just snapshots. But there's nowhere near enough sample rate on this for it to be useful capturing RF waveforms from video recorders. This probably has got enough sample rate for that, albeit it says 1 gigasamples per second, and I'm yet to prove, but I think that's shared between the channels, whereas the Tektronix is 1.25 gigasamples per second, and I think that's per channel. Again, all these I have to look up. But that doesn't have enough bandwidth for RF waveform. This might do, but if I can't display it real time to you, then it's no better than using the Tektronix one, other than the fact it's a lot smaller. So let's see if I can look that up, and I'll come back to you. Okay, it transpires that I should have set something up in here. It's communications, continue data download, which is not at all what I would have expected it to say for continuous data download. Right. So it should be updating. Yes, it sort of is. But it's more a succession of very slow updates. That's not live video, is it? It's also not an exact replication of what's on the screen. Could I demonstrate tweaking an RF signal from a video head? Maybe, but it's not really. It's this down here, this 2 kilobit thing, which is not updating fast enough. Maybe if I used a different port or a different computer, that would work better. Let's try plugging it into a different port. I'll use a different cable as well, though I may have to reconnect in doing this. Okay, so get data now and keep getting data now. That's the button I should have pressed. It's crashed again. It seems to really not like the port I've used there. Let's go back to another one. Okay, we're working on that USB cable. So if I do communications, continue data download, yeah, it's just as slow. So I don't think it's a cabling or port issue. Okay, well, the only way to really prove if this is going to be satisfactory for looking at the RF envelope from a video recorder will be to connect it to the RF envelope of a video recorder. So I will do that. That will be one of the things I try. One of the things I'm concerned about also is whether there is isolation on the USB port. The 01, I seem to remember there were 2 versions of this, one with the isolated port and one without. And I believe this is the I version. This has got the isolated port. I'm not sure if this is going to be true, and if not, that could inject noise into the system. So how can I test for that? I guess I unplug the USB port here and do a ohms test between here and the port. I probably should do that with the oscilloscope switched off. Okay, 1 ohm something. So no, there is not isolation on the USB port, and that for some measurements could be a showstopper. You wouldn't necessarily be able to make some measurements when you're connected to all the noise coming out of a computer's USB port, or if you're trying to make differential measurements or some measurement where you're not working at ground potential. In fact, that could be dangerous. The next thing to do then is to actually connect this to a video recorder, its RF output. Now I actually do have a project that I need to set up the RF envelope with, which I don't know if you remember. I did a video recorder repair some months ago now. It was a JVC HDV deck, and it was one of these strange video recorders which is the only model of that format. So it can record HDV 720p on large format DV tapes. Only that machine can play its tapes. There's no other machine that can play them. And the machine I've got, I managed to repair a heap of faults on it, but I got it to the situation it was trying to work, but it's got a tape path alignment error, and I did try initially to adjust that out and failed. So I need to revisit that one. But I think that's a little bit of a job, that one. So I think I'd rather just have a look at something a little easier. I'm going to use a Sanyo Betamax VTC5000 or similar machine that I have handy in the workshop, and I can connect to the RF outputs of that and look at the head FM envelope, which I've done many times before on the Tektronix. So we can have a look at what it looks like on this one with potentially less sample rate. One of the things I was thinking is, if the sample rate is shared between both channels and I'm using a second channel as a trigger, possibly no way of switching off that channel on the display if I'm triggering with it. So I end up using up half the bandwidth to display a trigger signal, which is just a flip-flop I'm not really interested in. I need all the bandwidth for the main channel, the one that's going to be picking up the RF envelope. So those are all the thoughts that are going through my head. The only way to find out really is to connect it up. Right, it's a little bit late in the day today. I will do that tomorrow, and I will be back shortly to you. Okay, let me show you what I have set up. I have a beta test tape playing on this VTC5000. There's a port at the back just behind the scope here, you can't quite see. It's got 3 terminals. They are RF, ground and head switching pulse. So the head switching pulse is on channel 2, the RF is on channel 1, and yes, we most certainly could set up the RF envelope. I'm adjusting the tracking here. You can see the RF envelope here quite clearly with this 1 gigasamples per second capture. If I adjust the tracking, we can see that the waveform distorts. It's a little bit low at the entry side to the head, actually, so that implies that I should probably adjust the input guide very slightly on this video recorder. Now, one of the things I was interested in is whether I need to display channel 2, because that's only my trigger signal. Can I have that triggering without it being visible on the display and thereby potentially soaking up half of the sampling rate? So if I switch channel 2 off, how do I do that? Press and hold it or just touch it? There we go. Okay, it's gone and we've lost synchronization. That's just rolling through now. So I can't avoid that, and that's unfortunate, because if that is using up half this sampling, you know, that's just to display a square wave I'm not interested in. I only want it to be there to trigger the scope. So nonetheless, there does seem to be enough sample rate to get away with it. The O1, if you remember, the sample rate on that one, when I tested that some time ago, was not high enough to really be usable for setting up an RF envelope. And another oscilloscope I tried, well, it was just beyond it, to be fair, was this little device here, which is Tool Top ET120 MC2, and it's a nice little scope, but you cannot expect it to do this sort of thing. The sample rate's too low, so even though it's got enough bandwidth for non-repetitive signals, you can't see them. So this is a non-repetitive signal. So everything here is working fine. We could certainly use this scope here to set up the RF envelope. But what I wanted to be able to do was to be able to demonstrate it to you on a PC so you could see a live video capture. And you can see that it is updating the data every several seconds. But that's not really good enough, is it? Because if I go in here with a screwdriver and start adjusting the RF envelope, the guides to improve the RF envelope, that happens in a matter of seconds. I can't wait for that to update. So it's not fast enough. The data stream is just not fast enough to be considered to be a video waveform that you guys can see when I'm working on equipment. So the O1 won't do it because the sample rate's not fast enough, even though it's got a good screen refresh. The little one won't do it because it hasn't got enough sample rate at all. And this one won't do it because the feed down the USB cable is too slow. And the Tektronix won't do it because it hasn't got a connection to the PC at all. So I still don't have an oscilloscope that will give you a live waveform. Now, if anybody knows how to improve the data rate of the live streaming on the Hanmatek, let me know. It might be something I can do with cabling or USB ports, but I suspect not. Okay, on the plus side, it is small, so I could potentially sort of set it up as it is now, and you can kind of see it. But unlike this thing, which I have to sort of move over here, and it's really awkward. I can't put that on top of a video recorder in my workspace. It's too bulky. So it's small enough that I could possibly get away with that. However, once I've removed this can here, so they can actually get to the head guides, not so much. So it's only a partial solution. But okay, at least it has a good enough sample rate, which is one of the most important things. Right, we've learned some things from that. I hope you've enjoyed what we've done there. We'll do some more stuff in a moment. Going back to the TinySA, look, I can see now why he had two. You can have one as an output and the other as an input. Well, actually, you can go from output to input on here, and indeed that's used for calibrating. But it can be useful. For example, here we're doing a sweep. So depending what you're doing, such as setting up, aligning a radio receiver, it could be useful to have one as an output and the other as an input by low and high. This isn't low and high signal level, it's low and high frequency bands, and there's more precision available with a low. So these arrows mean it's in and out. So having two of these does make sense. Good. Right, I asked a question about whether you can connect these directly to computer. The answer is, of course, yes. So let's briefly just do that. In order to connect it to the computer, it's recommended that you first update the firmware. And before you're doing update the firmware, you should do a self-test. And you connect the two ports together and select self-test. And I've done that for this one, and I've updated the firmware for that one. But for this one, I think we're going to fail. Config self-test. And it says test above critical, touchscreen to carry on, and it's just failing most of the self-tests. So this one, we're not going to do a firmware update. I think this one is probably not going to work. But this one, we did the firmware update, so hopefully we can connect that to the software in a moment. Yes, that's a little bit sad, isn't it? So only this one is likely to be a usable one. A quick note about the firmware. In order to connect to the PC, you need firmware version 1.4.120 as a minimum, but preferably 1.4.177. So that's the key thing, 177 at the end. That would give you the fastest link speed. But actually, when I went to download the firmware, I found that the latest was 1.4.175. So only 175, not 177 at the end. But still, it's new enough that the link will work, but it won't necessarily work at the full speed. We'll ignore that for a moment and carry on. Let's see if we can connect this to the PC. I should say also that doing a firmware update isn't the easiest thing in the world, but there is a great YouTube video by Kirk Poulsen which more or less explains what to do. So you have to install some extra software in order to do the firmware update. A little bit fiddly, but we got there.
Okay, I've started up the software here. This may not be the only software available for this instrument. And I'm having a bit of trouble connecting it. It seems to connect via a virtual serial port. In this case, I'm on COM3. Even though it's on a USB connection, clearly, when I go connect, it connects there. So it implies that it has connected. And if I say, look at the battery voltage, we're getting a plot of our battery voltage internally there. So we do seem to have a connection to the device. But can I get any of the images off the screen? No. I don't know what I'm doing here, but no, that's not it. How do I get it to reflect that screen onto the PC? Oh, bit like that. Okay. It seems to work. How about that? So it's not just reflecting this as an image. You actually drive it from here. So you do all your settings from here. Oh, okay. Right, that's better. Let's try that then. See if we can get a sweep with this possibly defective device giving us the output. Okay, that works. So I'd set this to output 100 megahertz and this to display that, and we're getting the same, pretty much the same display on the PC as we are on the device itself. And of course that, as well as being a lot more readable, is great because you can store it, and I'm sure you can also download all the data and analyze the data with spreadsheets and similar. So that is impressively capable, but none of this is exactly easy to use. It's all a little bit hands-on, which is great if you're really into this, sort of high frequency stuff, but it's not for the faint-hearted. Next thing I'm going to look at is the Atlas LCR meter, and I'm going to see, and I don't know if this is going to work, okay? I'm going to see if it's possible to detect which of the heads of this head drum, is it N1500 or N1700, I forget, VCR or VCR LP. One of these heads has failed. I think it's a VCR LP. And what I'm going to do is desolder them at the top. I did look at the bottom, but the wires are a lot finer there. Desolder them at the top and see if I can detect a significant difference in the inductance of the two heads. Also, I think you can set different test frequencies on this, so I'll set as high frequency as it'll let me do. Okay, so that's not that easy. Desoldering these shouldn't be too hard, should it? I have a microscope, so I can look down on it and desolder them, and then let's connect this and see what we get. So I have nothing to lose here. These heads are beyond use anyway. Let's just see if we can make a measurement. Okay, we can make the measurement. I've had a quick look at the user manual. It should set automatically to 200 kilohertz, and these are not the original probes. And I might try to get hold of a pair of the original probes for it. Okay, so going over here initially to this side that did have the black and red wires. They're not touching, so do the test. Oh, low resistance and inductance, so 1 ohm, inductance 0.4 microhenries. It might be towards the bottom end of what it can measure. Okay, let's go to the other head. I think this is so far off its range that I don't think we're going to get any meaningful answers from this. Alright, try again. This is the other side, making sure the probes aren't touching. One ohm, 0.6 microhenries. So I think that's too far off what it can achieve. It's designed to do. So, okay, this is not going to work as a video head tester. If anybody knows how a video head tester works, then let me know. Oh yeah, look, 200 kilohertz. So that's the frequency we wanted. Perhaps really this needs a much higher frequency to do a test with in the megahertz area. Let's try a slightly bigger inductor. How about the coil on a relay? which pins? I think these pins, yes. These pins are the coil. So what do you reckon we'll see? Certain amount of millihenries, I'd have thought. I mean, there's a fairly big chunk of copper in there, wound in the relay winding. So let's give that a go. Oh, did that say it needed to do calibration? Yes, okay, that's much more like it. So 55 more or less millihenries. What else we got? About 40 ohms resistance and 1 kilohertz. So a much lower test frequency because of the much higher inductance. And that's all of them. Okay, and I think you press and hold to switch off. Yes. Okay, to do, well, probe compensation. We'll do that. You put a piece of wire between them and press and hold on test. Right, okay, but on a non-conductive surface, and this mat is statically conductive. So let's move that out of the way. Right, now press and hold. Please short the probes. I am. Now open the probes. Okay. But it says calibration due. Didn't I see that? It said cal due. Let's read that again. September 2004. Yes. So we need to bear that in mind. It's way out of calibration date. Right, it can also measure capacitance, but since it can't measure series resistance, ESR, I will always use the ESR meter, which is a better choice. Though I suppose I could compare the two to get a reading. That would be worth doing, wouldn't it? Let's dig out this. So this is 2200 microfarad, 25 volt capacitor. First on this ESR meter. So 2152 and very low ESR. Now let's try this. So we're looking for 2152 or thereabouts if they have the same calibration. $21.68 if we're looking at the same units as the other one. That's very good. DC frequency, okay, it doesn't tell you ESR, but they're within a very small percentage of each other. I'll calculate what the percentage is later. I'm briefly looking at some of the other goodies. I can't readily test this right now. It's a signal strength meter for television, digital television. I probably have a Type K thermocouple somewhere. Oh, hang on, I can see one. Let's have a look. Look what I found. But it's got the wrong probes on the end. That's got 4mm. That's unusual for Type K. They should have that type of probe. So that's not very helpful. Somewhere I might have one with the correct type of plug. Oh, look what it can do. 2 temperatures and the difference between them. That's interesting. Right, and well, I use one of these frequently. This hot air gun, essentially the same as the one I have. This is something I've never seen before. You know, is it an old-fashioned desolder pump? But it's also got the soldering element in it. That's an unusual design. So I'm going to give that a quick whirl, shall I? It's just, you know, there's no reason that should be better than this, but I don't know. It's interesting. Let's try it. Do you need to be careful where you put this? I guess you'd really want to put it in a soldering stand if you can. But it doesn't fit my soldering stands, so yeah, that could be an issue, couldn't it? Maybe it had one. Maybe you could find a suitable stand for it. I think, really, for safety's sake, that should have a stand of some sort. Recently, I had an unholy job getting one of these hybrid modules out of this location here on this board to send to somebody. I was using desolder braid and soldering irons and heat and desolder pump, and I was getting nowhere. So let's just have a look and see if I can desolder some of these pads using this one. But, you know, being double-sided, I don't think this is going to work that well. But we'll give it a go, and we'll have a look at it under the microscope. So here we are looking at this hybrid module here. It's not going to be easy to work on, is it? Okay, well, it's smoking like a soldering iron. So I have some fresh solder as well. So let's first melt the solder on the pin. Is that working? And then see if we can solder it, desolder it, suck it up. Well, that was more successful than I was expecting. Try this next one. I'm not going to try the very next one because I think I'll resolder it, but let's try that. Do you know, that is much more successful than I was expecting. I suppose one problem being, though, I'm tending to resolder the one next to it. The question is, I suppose, is it taking the solder out from the hole of the hole, you know, the through plate, or is it leaving it in there? And I think it is leaving it in there. The question is whether it's clearing it all the way out. Is the pin free to move, or is it still stuck to the sides? And that one may be free to move, just maybe. But I don't think it's cleared the hole all the way through on those. Let's have a look at the top side. So it's the first 3 pins along here. So this is one I think may be cleared. The capacitor in the way, get out of the way. No, it's still soldered at the top. So for this double-sided board, this is from a Panasonic Super VHS machine. No, it's not working any better than my other solutions. None of my solutions worked very well for this board. It was extremely hard getting that part out. Ugh, yes, okay, I'll let that cool down. That's an interesting thing, and I'm not saying it's not a good solution, but is it a better solution than the electric one where you can keep trying? With this one you have to reset it. You have to, you know, once you've pressed your button, you have to, ooh, if you saw that, puffed smoke out. You have to activate it again. I do wonder what the temperature is on this. It seems pretty hot. Maybe it's another tool in the arsenal of desoldering difficult parts, but it wasn't able to clear those wires. Right. Well, we've enjoyed what we've done with this fantastic set of equipment that we picked up from my friend Brian. And I know we've only scratched the surface of a lot of it. There's a great deal more we can do with the TinySA. We haven't even looked at the USB interface on the signal generator, and I'm sure there's more we can do with the oscilloscope as well. So if there's anything in particular you'd like me to go into in a bit more depth, just let me know. In the meantime, I'll do plenty more content on audio and video technology in the near future. Bye for now. big thank you to Brian for letting me have this equipment. I know it's hard letting stuff go, and you know, he, like me, has always enjoyed working with electronics. So it was important to him that this equipment goes to someone who's going to use it and enjoy it, and I promise I will do that.